Welcome back to lecture 18 on financial mathematics for actuaries. Today the topic of discussion is future value of annuities, S angle N. In the last class, if you recollect, we have discussed something like borrower's perspective. If I have these many monthly payments that I can make, then how much should I borrow in order to satisfy my needs, right? That was the goal in the last lecture. So our focus was borrower's perspective. We were doing all payments on a yearly basis, and then we actually calculated what is the amount that I can borrow today. Or we also looked at, if I borrow this much amount, how much amount I need to pay in certain duration of time. Or the third question that we address is, what should be the value of N if I have taken this much amount and I am willing to pay this much amount on a monthly basis, right? So that was about previous lecture where we were dealing with present value of annuities. In this lecture, we will change our focus to saver's perspective. So if I want some amount in future, say $X, then how much should I save starting from now? So for that, we will design a tool called S angle N, which is future value of money. In order to do this, let us design a roadmap for today's class. First, we will see how this visualizing accumulating wealth is a snowball effect. We will design in that way, and then based on that snowball effect that we have seen, we will be able to relate it to the present value of money, and then we will derive the future value of money, which is SN. Okay, and then we will officially connect SN with AN, that's the golden link, and then we will discuss one common trap, which is valuation date trap, and we will finish the lecture. So reference mapping as usual, Browerman section 2.1, Chan and Say sections 2.1 to 2.2. So let us start discussing how to go for future value of money. So let us visualize first. As we have already discussed several times, money has a time dimension, or there is a time value associated with money, and based on that, $1 sitting at time point 1 and $1 sitting at time point n cannot be the same, right? So this $1 sitting at time point 1 will grow for n minus 1 steps if the interest rate is I as 1 plus I raised to n minus 1, and the $1 sitting at time point n will earn no interest. Okay, so the money that you invested earlier works hard, and it is the hardest working capital that you have. So the earlier you save, the better off you are. That's what the traditional wisdom is, and that's what is being revealed here. Okay, so now how will this drive us to derive the formula for SN? So let us look at the simple thing which we will do for this interest rate calculation. We already know, if I want to design a future value for $1 invested at each time point, the first time point 1, second time point 1 plus I, third time point 1 plus I square, and n minus 1 at time point 1 plus I raised to minus 1. Here I am actually reversing the direction. If you notice, I am starting from nth time point. So if I start with nth time point, this number is going to be 1. If I go to n minus 1th time point, the number is going to be 1 plus I, and so on and so forth. When I reach this time point, it will be 1 plus I raised to n minus 1, as I stated here, correct, and at time 0 there was no investment. So this is how you will actually calculate the time value of money, which will be denoted by future value. Okay, so our focal date is time point n. So what we are looking at is nothing but a geometric series. where the first term, that is the nth value, is 1, this is the last payment, and the common ratio it is getting multiplied by is 1 plus I, which is greater than 1. Terms, how many terms are there? There are n terms. Okay, so now this is appealing to our geometric series sum formula. It will be A into r raised to n minus 1 upon r minus 1, because 1 plus I is greater than 1. Okay, so if I appeal to that formula, this future value formulation becomes 1 into 1 plus I raised to n minus 1 upon 1 plus I minus 1. So this is just a notational assumption, you can just trim this off. This gives me the golden formula for our future value of annuities, which is 1 plus I raised to n minus 1 upon I. Okay. Now, how this formula actually relates with our AN. So, we will look at that link first, and we will call that link as a golden link. So, whenever I am calculating present value of annuities, I am looking at time point 0. So, I am bringing everything to time point 0 and calculating the present value, right. So, what is the analogous transformation for that? If I want to consider future value of this present value, I should move this n time steps forward. Okay. So, if I move this n time steps forwards, this present value will earn interest for n time steps with compounding. So, I will multiply it with 1 plus I raised to n, and then what I get is the future value of that annuity. So, we have established a connection. Sn is equal to A angle n into 1 plus I raised to n, which essentially satisfies fundamental mathematical need, that is paying off a loan versus saving for the same payment should yield same mathematical block value. Okay. So, we are very much clear that whether I am calculating AN, which is present value, or SN, I can relate both of them, and they both are equal with this formula. Okay. So, the mathematical value of them will be equivalent depending on which time frame they are. Okay. So, once that is clear, then we can actually look at one common example which many of you must have thought, that is the retirement goal. The goal is any plan, any term life plan or term insurance plan, they preach you that you save this much amount for next these many years, you may earn interest of this percent, and then finally when you reach 65 or something, you will get this much value. How to compute that? That's the idea here. So, here is a problem where you are saving 5,000 at the end of every year. Okay. So, this is at the end of every year for 30 years. The effective interest rate given to you is 7%, and you need to find the future value. So, is everything which we need to compute there? The answer is yes. So, what we are looking at is this S with angle 30 claiming interest at 7% per annum. Do I know this value? Yes, I know. This is going to be 1.07, which is 1 plus I raised to how many years are there? 30 minus 1 upon the interest rates, that is 0.07. So, I know this. Okay. But this is for $1 that is invested. How much you are investing? 5,000. So, your future value will be equal to the amount that you are investing every year multiplied by this S 37%. Okay. And then I can compute this value. So, let us skip the computation and see the printed solution. So, this is what I mentioned, and therefore, the answer to this is 4,72,304. Let us analyze how much interest we have gathered. So, we call that as interest analysis. So here is the interest analysis. You have actually deposited in terms of cash, how much cash you have deposited. Over 30 years you have deposited 5,000, right. So it becomes 1,50,000. The interest that you have earned is 4,72,304 minus 1,50,000, which is whooping $3,22,304. What does this mean? The compounding principle rocks. Compound interest actually did more work than your investments. Okay, so this is an in-depth analysis of interest rate given here. Let us now master these steps in our BA2 plus calculator. Okay, so let's move on for the calculator steps after doing this interest rate analysis. So here is a calculator, and here are the steps. So what I need to do is, first I need to check whether the calculator is in end mode. Yes, it is. I will first clear TVM, then I will start with the actual data input. I have number of years which are 30. Interest per year is 7%, so I will include that here. Then what will be the present value of the investment? There is 0 present value currently, so it will be 0. Okay, and then how much I am going to deposit every year? I am going to deposit $5,000. Okay, just get one step backwards. So I am going to deposit $5,000, so it's a outflow from my end, so that's minus 5,000. I will put it in PMT. So once I have put this, there is everything is set. I just simply need to calculate the future value. So call for compute, call for future value. It gives me 4,72,303.93. So this is mainly because of some rounding errors. So this is the positive inflow that we have shown here. Okay, so we have solved the problem mathematically and via calculator. Let us now move on, and it's time for you to test your skills. We will pose a problem that we have a millennial goal. That means I want to earn 1 million in 20 years. A bank is guaranteeing me to pay 8% annually. How much should I deposit so that I will get 1 million at the end of 20 years? So I am depositing at the end of each year. Okay, so pause this video and see the answer. Okay, you must have used the PMT value and the actual calculation, or you could have solved this problem using your calculator also, right. So whatever you have done, we will show the mathematical analysis of this solution. Okay, first of all, my goal is 1 million. I don't know how much to put. I know it will be accumulated for 20 years and at 8%. So I will essentially figure out what should be the PMT. Do I know what is S20 8%? Yes, I do know. With this formula, I can easily compute. It's 1 plus I raised to n minus 1 upon I. So I can easily compute that, and it turns out to be 45.762. So I will divide this 1 million by 45.762 to get the monthly installment that I need to deposit. Sorry, yearly installment that I need to deposit. So 21,852.17 is the yearly installment that I need to deposit. Okay, so here what we have done, we have said that at the end of each year. What if we begin from that year itself? Okay, at the beginning of the year. So that is where we are shifting one time slot ahead, and that comes in the regime of annuity due. So we are starting at the beginning. What is the impact? Let us analyze that impact. We have already seen you don't have to worry about this annuity due as a separate issue, because you simply multiply by 1 plus I, you will get the answer. Okay, so if I do that, that is I am multiplying by 1 plus I to this 45.762, because the money, the entire cash flow will be sitting for one more period. Multiplying by 1.08 will give me the legitimate answer. It becomes 49.423. That means if I start at the beginning of the period, I need to pay yearly installments of 20,233.50 rather than 21,852.17. That means again savings early will save you some money. Okay, so this is an important takeaway from this lecture. Saving early saves you the money. Okay, so now let us look at the valuation trap that we actually come across in several problems. So here is one trap. The scenario may say that you have to save for 10 years, leave the money idle for 5 more years, and you are evaluating the value at t is equal to 15. So generally what happens is you ignore this leave money alone for 5 years, okay, and you actually compute S angle 15. This assumes you are actually paying for 5 more years. So you should avoid that trap. You should never use this trap, because the payments have stopped at time point 10, and what we are doing is we are actually gathering interest with 1 plus I over that. So final value will be 1 plus I raised to 5. So what we need to do is we need to take those payments up to S10 and multiply them with 1 plus I raised to 5. That is what is the correct answer. So this is very important, as you might miss out many marks if you ignore these some hidden subtle cues. So just keep these things in mind, and that will help us in doing better in the exams. Okay, so we have done a lot. Let us summarize what we have done. What we have done is, first we have determined the accumulation, which is the future value of annuities given by this formula 1 plus I raised to n minus 1 upon I. Then we established the link between future value and present value of annuities, and that link is just a multiplier of 1 plus I raised to n to present value of annuities to get the future value of annuities. Then we did the interest analysis, where we actually calculated the total interest, and in the case that we have shown how the compounding worked more than what you have worked, right? And then we looked at the timing. That means the annuity when it is stopped, when the last payment was made, and then it is held. So the timing of SN is very important. In our case, that amount was held for 15 years, but the payment was done, last payment was done at the end of 10th year. So it was S10, not S15. Also we showed the connection with S double dot angle N, which is the annuity due, future value of the annuity due, and what we have done in S angle N is future value of annuity immediate, right. So next up we will solve some problems where N is not an integer, or the regular regime where payments are not done annually, payments are done monthly. This will become a real connection with our real world scenarios. Okay, see you in the next class. Thank you.